Okay, you guys, last section of 11.3 is the difference between two proportions for a confidence interval. So this is our very last test. It's the 8th test we've learned in this unit. So I have the cheat sheet that I'll give you after that's got kind of everything. So we're only going to do one example, so it's going to be super short. So the first part is the conditions. So the conditions haven't changed. The samples are independently selected, or the treatments were assigned at random to the individuals or objects. And then, so that's condition 1. Condition 2 is both sample sizes are large. So again, you're going to have to check N1 times P1, N2 times P2, N1 times 1 minus P1, N2 times 1 minus P2. And this time, actually, since we won't have P's, we're going to be using P hats. Because they're only going to give you sample proportions in the problem. They're not going to give you any regular population proportions. Okay, so then we can still say by the central limit theorem, whatever. Okay, condition 3, this is going to be a 2 proportion Z interval. And I'll show you where that is on the calculator. And then condition 4, you're still going to want to define proportion 1, proportion 2. And again, it doesn't matter which one's which, just know that whatever one you pick first, it could matter in your actual interval. So here's our formula. So p hat 1 minus p hat 2. Remember, it's always the statistic, plus or minus, and proportions are always z values. So our z critical value we're going to have to find. And then times, here's our standard deviation. Sorry guys, I was trying to find the formula sheet. So our standard deviation here is p hat. It's the same one here as the difference in the sample proportions, except this time we're using p hat instead of p. So it's still this one. See how they match? There's no p sub c here since we are using sample proportions only. Okay, like I said, there's no hypothesized proportion. We're only going to use sample proportions. So there's no p sub c, thank God. So on the calculator, you're going to use 2 proportion z interval, which is test B. Okay, so on your calculator, if you go to our test, it's all the way down. It's right under, we used A in chapter 10, we're at B. And if you plug it in, you'll see. Okay, I'll get to that in a second. And then the conclusions will be similar to our means, and we'll go from there. So let's try our example. A student assignment called for the students to survey both male and female students, independently and randomly chosen, to see if the proportions that approve, this is a typo, of the college's new drug and alcohol policy are different. A student went and randomly selected 200 male students and 100 female students and obtained the data below. So here's their N1, N2. This is X1, X2. This is P hat 1, P hat 2. Okay. Use this data to obtain a 90% confidence interval to estimate the difference of the proportions of the male and female students. So you're going to have to write kind of small because we only have like a half sheet. So our conditions. So first we're going to look for random samples and independent. So P hat 1 and P hat 2. I'm going to use F and M actually. Are both from simple random samples and independent. Okay, now we gotta check condition 2. So N of the female times the P hat of the female is just going to equal X, so that's 43. So that's greater than or equal to 10. N of the male times the P hat of the male, that's 61, greater than or equal to 10. The number of female times 1 minus the P hat for the female if 43 said yes, that means 57 said no. So that's greater than or equal to 10. N of the male, 1 minus p hat of the male. So 200 minus 61, 139. So all those are greater than or equal to 10. So I can just use the regular numbers, the x's, since they were given. But if you were given a percentage, you'd actually have to figure it out. So now we can write, therefore, both sampling distributions are approximately normal by the central limit theorem. Let's go zoom back out. So condition 3, remember this is your test. So we're doing a 2 proportion z interval. Okay, and then defining my variables, I'm going to say P of f is the true proportion of females who approve of the new policy and P of M is the true proportion of males who approve of the new policy. So for testing, we don't have a ho and a ha because it's a confidence interval. So p hat for the females was 0.43. P hat for the males was 0.305. All you're doing is rewriting what's in the table. X of f, x of m, n of f is 100, n of m is 200. And then we had to find out our z critical value, which from the formula sheet, we're doing a 90% confidence interval, should be 1.645. So then let's figure out our formula. It would be 0.43 minus 0.305 plus or minus 1.645 times the square root. Now we got to do p hat 1 minus times 1 minus p hat 1. So 0.43 times 0.57 over 100. So if this was a 1 sample, that would be like your standard deviation. Since we have a 2 sample, we got to add in the other one. 0.305, 0.695 divided by 200. So there's your formula. Now I'm going to plug it in the calculator. So remember, go over to test. We're in test B. 2 prop z in. So x1 was 43, n1 was 100, x2 is 61 out of 200. And remember, when you do these on the homework tonight, you can't put a decimal in for x1 or x2. So if it just gives you the proportion, you have to round up to the nearest person. And we're going to 90% confidence interval. So if I hit calculate, there's my interval. I'm going to write it over here. 0.02754 to 0.22246. Okay, so our conclusion sentence, we're going to have 2. One is going to be like the regular confidence interval, and then the second one we got to talk about in this confidence interval, both endpoints are positive, which means I looked at the females first, so it looks like the more females approve of this policy, since both our endpoints are positive. If both endpoints were negative, it would be males that the proportion of males was higher. Remember, if zero's in there, there could be no difference. But your first part of your conclusion is just to write our normal confidence interval sentence. We are 90% confident that the true difference in proportions, in proportion of female versus male students that approve of the new policy is between 0.02754 and 0.22246. Okay, there's no units because we're doing proportions. And then we just got to add in, since both endpoints were positive, the females, more females approved the new policy. So since both endpoints are positive, it appears a higher proportion of females approve of this new policy. Okay, so remember, with confidence intervals, you always want to give that second sentence that talks about the interval. What does it really mean? Okay, so that's it for chapter 11. You're going to get what I have, my version of the cheat sheet, next. I wrote out all 8 tests that we did in chapter 11. So this was starting from 11.1, 11.2, 11.3, and then finish it up. On the back has to do with confidence intervals, what I just went over. Okay, so you can use this on your homework tonight and help you study for the test on Thursday.